All right, good day everyone. Welcome to my channel once again. Today, without wasting much time, we'll be going straight into the subject we're having on the board. As we can see, simple harmonic motion. Now, firstly, before we go to the calculation, remember we're preparing for external exam, JAM. Most of their questions are calculation based, but we also have few theory questions. So you should have some little foundation on the theory regarding the subject matter. So firstly, let's start with the definition. What is simple harmonic motion? Simple harmonic motion is the motion of a body or a particle in a straight line. Okay, so the first keyword you should know is simple harmonic motion is the motion of a body or particle in a straight line such that the acceleration of the body is always directed towards a fixed point and is directly proportional to the displacement of the particle from that fixed point. Now, for this to make sense, a common example of simple harmonic motion is the motion of a pendulum bulb, which students are usually tested for in external examination. So, for a pendulum bulb, we have a setup like this. So, we have a bulb. When this bulb is distorted, this position, this axis, is known as the equilibrium position or the mean position. At this position initially, the bulb would be at rest, but when distorted, when disturbed, it would move to and fro. So simple harmonic motion is also a to and fro motion. So the particle moves to a certain extent and then stops, swings back through the equilibrium position to this other direction, and it goes on. But due to the effect of friction in the environment, at some certain points, the motion would die off. So this is the setup of a simple pendulum. So let's go over the definition again. First of all, simple harmonic motion is the motion of a body or particle in a straight line. Now, this is actually an arc of a circle, so it doesn't really look like a straight line. So the part of this motion that is undergoing simple harmonic motion is the fact that by the time this body moves from this point, so let's call this point O, let's call this point A, let's call this point B. By the time the particle moves from O to A, we would notice that the particle would have traveled a certain height upwards. And that height is from this point now to this level. So that is the height that this particle has moved through. So by the time this particle drops back to the equilibrium position, it falls from this height now back here. By the time it goes back to position B, what happens? It travels back that height. When it drops back, it falls down this height. So what do you notice? It means that as the particle is traveling through this arc, it's actually undergoing a vertical motion, a to and fro motion on this vertical axis. So it is this to and fro motion that is actually the simple harmonic motion that we are doing what we're talking about. So the simple harmonic motion is not essentially the length of the arc covered by the swing. It's actually the vertical displacement, the to and fro vertical displacement of the particle. Now that said, what are the common questions that are usually asked regarding the simple pendulum? Okay, now, okay, the first thing you should know, you should recognize is at the parts where this particle gets to position A, it will pause for a few seconds before dropping back. So it means at this very point, the velocity of the particle becomes zero. So in case you are asked in your exam, in which part of this motion is velocity minimum? This is your minimum velocity. It occurs at the extreme positions. Okay, so since velocity is equal to zero, remember that kinetic energy is equal to half mv squared. And if that is the case, if velocity is zero here, if zero multiplies everything here, it therefore means that the kinetic energy of the particle at this point is also zero. So you also have your minimum kinetic energy at this point. But then your potential energy, remember potential energy is given by the product of mass times acceleration due to gravity and then the height. So at this point, that is where you have the maximum height attained. So it therefore means that your potential energy is actually maximum at this point. So these are the three things you should take note of. Kinetic energy and velocity is minimum at this position, then your potential energy is maximum at this position. Now, the opposite occurs at the equilibrium position now. By the time the particle falls back to the equilibrium position, at this equilibrium position, that is where you have your maximum velocity. So at this point, velocity is maximum. And if velocity is maximum, it therefore means that what? Kinetic energy would also be maximum. But then at this point, the particle has not moved through any height. So the height at this point is zero. The vertical displacement at this point is zero. So if my height is zero, it therefore means that potential energy at the equilibrium position is zero. So whatever you obtained here also applies here. So these are the first things that you should take note of in the subject of simple harmonic motion. Now, without wasting much time, what are some of the formulas that are necessary for you as a student to actually take note of? Okay, so like I was saying, sorry for that break. Something came up, I had to attend to something. All right, so if we're to continue from this, I said, I think I was trying to say the formulas you should take note of when solving calculations on simple harmonic motion. They are not that much, so you just need to memorize them. The derivations for these formulas have dealt with in some other videos. I'll paste the link after the video. Okay. All right. So the first formula you should know is the formula for the velocity of the particle. Now listen. We said at the equilibrium position, your velocity is maximum. Okay. But then we said at the extreme position, your velocity is zero. We need a formula to be able to calculate the velocity of the particle at any instant in the motion, aside the extreme position and the equilibrium position. Hence, we have this formula that states that velocity is equal to angular velocity, the square root of your amplitude squared, then minus your displacement at that point. So what's the meaning of each of these terms? W means the angular velocity. And just in case you don't know, the formula for angular velocity, W, is equal to 2 pi f, or W is equal to 2 pi over t. What is frequency? Frequency is simply the number of oscillations or cycles covered by the particle per unit time in 1 second. So the number of cycles covered, so in other words, we can say frequency is equal to number of cycles per unit time. Okay, while your period, this capital letter T here means period, your period is defined as what? The time taken for this particle to complete one oscillation. Just in case you don't know what an oscillation is. Now, this is what an oscillation is basically. If the particle starts from the equilibrium position and moves to this extreme end, for you to understand, that is actually a quarter cycle. Please pay attention. By the time it drops back, it moves like this way. By the time the particle moves to this other extreme end, that is another quarter now. Then by the time it falls back, that's another quarter. So you can see that's your full cycle. So a complete to and fro motion, it's from the equilibrium position to the extreme, back to the equilibrium position, back to the opposite extreme, and then back to the equilibrium position. Please take note of that. So the time taken to complete that complete oscillation is what we call the period. So in other words, we can say period is equal to the time taken per oscillation, for one oscillation is what we call period. So looking at these two formulas, we can clearly see that frequency and period are reciprocals of each other. What do I mean? If you look at frequency, the formula for period is just the reciprocal for the formula for frequency. Hence, we can say frequency is equal to 1 over period. These are basic formulas that might come handy in your calculations. So, I've told you the meaning of W. W means the angular frequency or your angular speed. And the unit for your W, which is your angular frequency, is rad per second. Rad per second. Now, what is A? A represents your amplitude. What is amplitude? Amplitude is the maximum displacement of the particle from the equilibrium position. So, by the time the particle moves from here to this extreme point, your amplitude is the maximum. This maximum displacement is what we call the amplitude. Then X here represents the displacement of the particle from the equilibrium position aside the amplitude, the position of the amplitude. So if the particle should get to this point, if we are considering this part of the motion, your X becomes from this point now to this point. That becomes your X. So if you want to calculate the velocity of the particle at this very point, you use this formula. V is equal to W root A squared minus X squared. The second formula you should know very well is the formula for acceleration. So acceleration is equal to minus W squared X. Okay? So you already know what W mean and you already know what X mean. So this gives you the formula for acceleration. Now, what's the essence of this negative sign? When performing calculations, we don't normally make use of the negative sign. When performing calculations, we don't normally make use of the what? The negative sign. The negative sign only tells us that what? The direction of acceleration is opposite to the direction of your displacement. What do we mean by that? Remember that the particle is being displaced towards this direction. But then, so this is the direction for displacement. Acceleration, on the other hand, the body is always being accelerated towards the equilibrium position. So that's acceleration. Remember, acceleration is change in what? In velocity. So the change in velocity that occurs in this motion is always directed towards the center. So the body is always moving towards the center, which is the equilibrium position. So hence, since acceleration has opposite direction to displacement, that is the essence of the negative sign. But when solving, you don't really use the negative sign for your calculations. Then what other formula is important to us? The formula for period is very important. So in case you don't know the formula for period, period is equal to the period of a simple pendulum. This is the general formula for period, but the period of a simple pendulum is given by 2 pi root L over G. And then the last formula you would need is the formula for your maximum velocity. In case they should ask you for maximum velocity is equal to the square root of 2gh. The proof for all these formulas will be given in a different video because I don't want this video to be so long. So this said, we'll be going straight into calculation problems now. Let's begin. Okay, so we have our first example here, which says a simple pendulum with a period of 2.0 seconds has its length doubled. Its new period is dash. Okay, so this question is basically relating two things. What are they? The period and then the length of the simple pendulum. So you simply write your formula for period. We've already said that period is equal to what? 2 pi root what? L over G. So these are formula. Now, everything in this formula is constant. Pi is a constant, G is a constant. So it means that the period of a simple pendulum is dependent only on the length. So if you have two different pendulum, in as much as they have the same length, you should know that they are going to have the same period. So since 2 pi and g is a constant, we can simply say that our period is directly proportional to the square root of L. That is what it means. It means the only thing that determines our period is L, and then our L is inside the square root. So that's why I write this. So you can say period is equal to, in mathematics, you change this to equal to, and then you introduce a constant, then you have root L. So if you make your constant the subject of formula, you say T over root L would be equal to K. And if T over root L is equal to K, it means this quotient is always a constant. So it therefore implies that we can say T1 over root L1 is equal to T2 over root L2. I would advise that we all memorize this formula. So in subsequent examples, in subsequent questions you meet, whenever you see a question relating period and the length of the string, just make use of this formula and you would be fine. So let's bring out our parameters according to the question. So T1 is your initial period, which was given in the question. So T1 was given to you to be 2.0. So I say 2.0. L1, nothing was said about L1. They didn't give us the initial length, but they told us that that initial length was doubled. So we have a new length, which is our L2. So from that statement, if the initial length was doubled, they're trying to say L2 is twice of L1. That's the implication. The length was doubled. So it means the new length is 2 times the previous length. So that is what we have. So we are now looking, according to the question, they said its new period will be, if you change the length, what will be the new period? So we are looking for T2, question mark. So from here, if you should make T2 the subject of formula, firstly, I'm going to cross multiply, or you could just substitute directly. If I substitute directly, your T1 is given to be 2, so I would say 2 over root L1 is equal to T2, we don't know, that's what we're looking for, divided by root L2 is 2L1, so I'll say 2L1. So from here now, if we make T2 the subject of formula by cross multiplying, 2 would multiply this to give you 2 root 2L1, okay, would be equal to, what do you have here? You have T2 multiplying this will give you T2 root L1. This is L1, remember. So from there, if you make T2 alone, divide both sides by this, T2 would be equal to 2 root 2L1 divided by root L1. So our answer becomes 2 times. Now you punch your calculator, the square root of 2 would give you what? Please, students, help with that. The square root of 2 would give us what, please? Quickly, quickly. The first, the square root of 2. Okay? I'm waiting, please. I'm waiting. Oh, you guys are delaying. Yes. Yes.
1.4.
Continue to 4 decimal places. Oh, God.
1.4142.
Then your root L1 is still there. So you say root L1 divided by your denominator root L1. So you simply use root L1 to cancel out root L1. Your final answer becomes 2 times 1.4142. Result, please. Result. Final answer. Final answer, please.
2.8284
seconds. All right. So this becomes your answer. Looking at our options, the options are given in 2 decimal places. If you approximate this, your final result, please ensure this is captured, becomes 2.83 seconds. So that becomes your final answer. For this video not to be long, we're going to stop here. I'll solve more problems in the next video coming up. See you next.